Hello, welcome to another crypto enthusiast video. Thank you for joining. This is part 2 of a blockchain programming example in C++. So before we get started, I just wanted to take a moment and ask you to hit the subscribe button and then also hit the bell icon so that you'll get notifications when we upload new videos. Also, if you haven't watched the first video, go back and watch that. It's entitled Cryptocurrency, Bitcoin, Ethereum, Ripple, Blockchain in 30 Minutes in C++. And I'll link to that video at the end of this video. Also, I wanted to give some credit to Savjee. Savjee has a YouTube channel in which he has videos all about blockchain. And he has a particular video called Create a Blockchain in JavaScript. This video and the one previous to this are modeled after his example, so I wanted to give him credit. Go check out his videos, he's got good stuff. So about this video, this is a refactor from the first video where I refactor the C++ into class and header files. And I also just wanted to reiterate and touch on some important concepts about blockchain. Also a disclaimer, C++ is not my first language, but I wanted to challenge myself, so here we go. So if you watched the previous video, you noticed that I had everything in one C++ file. We had a struct in there, a class for block, a class for blockchain, and then a main function that used those classes. And that's not really the way object-oriented programming is done. Typically, you have things separated out into different files, and that goes with pretty much whatever language you're using, especially with C++. So I wanted to take some time to just refactor this and separate that out into different files. Now, one caveat with C++ that differs a little bit from other languages like maybe C# or Java is that you actually have to link files together in order to compile them into one executable. And that's not a trivial process or task. It is something that you can do through the command line, but it's easiest when you have a good tool. So on the Mac, one of the best tools for that is Xcode. So that's what I usually use when I'm doing C++ on the Mac is Xcode because you can target a certain executable every time you create a class. It will also create an optional header file for you. And so that's what we've done here. So I just wanted to go through a little bit of the refactor and then touch on some important concepts that we didn't really hit on last time. Also, if you're on Windows, Visual Studio is probably the best IDE to be developing C++ applications in. It's got great tooling, IntelliSense, and it packages everything nicely. So getting files linked together becomes an easy thing to do in Visual Studio. But on the Mac, probably right now, the program I like to use the most is Xcode. You can use Eclipse. You can also use Visual Studio Code. There's probably other things you can use. You might be able to just use a normal text editor and then use the command line or a make file to actually build all of your C++. But again, here, we're just using Xcode because it's easy and it works well. So in this main C++ file, we have included some headers. We have IOStream, CTime, vector. I talked about those in the last video. We've also included some new files, which are header files, because we separated those out into separate components. That way we can import them as needed. So let's look at transaction data real quick. Transaction data is a struct that just holds the data for each transaction. So we've got an amount, we've got a sender key, a receiver key, and a timestamp. And that's everything that we would need for, just a basic transaction. Let's also look at block. So block imports transaction data because we need it here in this header. And we've got the block class defined here with private members of index, block hash, previous hash, and a generate hash function. And then under public, obviously, we have the constructor, which takes in an index, a transaction data struct instance, and then also the previous hash, which is very important. And we'll talk about that in a minute. So we've got some public getters here where you can get the index, get the hash, get the previous hash, and then obviously the transaction data. And normally the transaction data would be a private member, but here we're just leaving it public for an example of how a blockchain might be able to be hacked and why the hash on a blockchain is important. And then also we have an is hash valid, which is also a very important part of this. Okay, and then in our blockchain header file, we've got some private members here. We've got create genesis block, which creates the first block on the chain. And then we have a vector of blocks, and that's actually our chain that's going to hold all our blocks. And then in public, we have our constructor, and then we have some public functions. Get chain returns a vector of blocks. Get latest block actually returns a pointer that points to a block in memory. And that's for demonstration purposes. Ordinarily, we probably wouldn't do that. We don't need a pointer for that block, but we're going to just show how block data could be manipulated by getting a memory address. And then we've got a Boolean function, or a function that returns a Boolean called isChainValid, and that just validates the whole chain, going through one block at a time and validating each block. And then also we've got an add block, which takes in a transaction data struct member. And then we've got print chain, and that's something that I added so that we could easily see what's in the chain. Okay, we're going to take a look at the block C++ file here. So we've included block and transaction headers, which we just took a look at those. And then we've got a constructor here that takes in the index, the transaction data, and the previous hash. And then we're setting the internal properties to the values of those arguments. And then our block hash here is generated by the value that gets returned in this function, generate hash. Okay, so in our generate hash function here, we are creating a string out of the transaction data. And what we're doing is we're taking each member out of that transaction data and we're concatenating it into a single string that we can hash. So you'll see on line 41 here, we are creating a hash and we're creating two hash values. One hashes the transaction data string and the other one takes in the previous hash from the previous block and combines that hash with this other hash to create a unique hash for this block. And that's a very important step because the previous hash is what cryptographically links this block to the previous block. And that's why if somebody does something to the transaction data or the block data of either this block or the previous block, it will invalidate this block. That's why it's called a blockchain, because these chains are cryptographically linked together. They're chained together by that previous hash. And so each successor, each ancestor, and so each successor to every block contains the previous hash. And that's an important step because it just cryptographically links all those things together. And so every block is then mathematically or cryptographically verified. And we've got some public members here. We've got get hash, get previous hash, and then obviously this is hash valid function, which is also very important. And this just calls the generate hash function and then compares that to the hash member that's already in this block to make sure that those things equal, because if they don't equal, that means something's wrong. And that means that this block is then invalid. Then when the nodes on the network are working on a consensus, they will see that if a block has been manipulated, it is no longer invalid because of this process. So let's look at our blockchain C++ file. All right, so here again, we're importing block and blockchain. We're also including vector. And in our blockchain constructor, we are creating the genesis block, which is the first block on the chain. And then we're pushing that, which is an important step, to the chain. So that is the first block on the chain. And then we've got a public chain getter here that returns the chain. And then we've got this create genesis block function. So here we're setting the current time and we're setting up some initial transaction data, which has an index of 0 because it's the first block on the chain. And then we're just calling it anything in here, the transaction data. So we're just saying this is the genesis block here. And then we're doing essentially the same thing. We're creating a string of transaction data and we've got two hashes to combine. And then we do what the boost library's combine hash function does, which is to combine these hashes into one. If you go look at the source code of that boost library, this is the same thing that that library is doing. So ordinarily you would use some security library or cryptographic library. Here, for example purposes, we're just using the standard library's hash function to do this. And this is good for an example. Or for something that doesn't have to be super ultra secure, you might create a blockchain like this, maybe for an internal application or something. And then we are creating this block and then returning the Genesis block. And that gets added to the chain here in the constructor. Then we've also got this pointer here for get latest block. Again, this is just a pointer for demonstration purposes so that later on we can invalidate a block by manipulating data inside the transaction data. All right, and then we have this add block function here, which takes in some transaction data, sets the index based on the current chain size. So if this was the Genesis block, then that index would be 0 because the chain doesn't have any blocks in it. And then the next block will have an index of 1 and so on. It's 0 based, just like an array. And then we get the previous hash by grabbing that latest block that's on the chain and getting its hash. If it doesn't exist, then we're just going to put a 0 for the previous hash because there is no previous block. And then we're going to create that new block out of that index, transaction data, and the previous hash. And then when that gets returned, we're going to push that onto the chain. And then we have this isChainValid function here, which just returns a Boolean of whether or not this chain is valid. We create an iterator that iterates over a vector of blocks. And so for each item in the chain, we iterate through it and we set the current block to this current iteration. And then we check to see if that current block has a valid hash. And if it doesn't, we return false. And then we also need to check to see if this is the first item, because if it is, we can't compare this block's previous hash member to the previous block's hash member. So if this isn't the first item in the chain, then we grab the previous block by decrementing the iterator by 1. And then we compare this current block's previous hash with the previous block's hash. And if those things do not equal, then we know that this block isn't valid and we return false here. If either of those conditions don't return false for this current block in the iteration, then we just keep going through each block in the chain to make sure that that block is valid. And if all the blocks are valid, then we know that the chain is valid and we return true. And then we've got a print chain function here that I created just for convenience so that we can see actually what's in each block. And like the function above, it just uses an iterator that iterates over a vector of blocks, which is essentially our chain. And for each item in the chain, it prints out all the details about that current block. And we're using the print format function here, the printf function, which just prints out a string to the standard out. And it uses a format specifier to specify the type of formatting that you would like to do on the current argument. So you can actually string these together and do things like, %s and %f. And then for each one of those, you have to add a new argument here. So you would do something different for each one. That's our print chain function. All right, so we're going to take a look again at this main C++ file. Inside of our main function here, we are initializing a blockchain. We're going to call it awesome coin because it's awesome. And if you remember inside constructor for blockchain, we are calling a function called createGenesisBlock. Let's go take a look at that now. So we've got this createGenesisBlock function, which previously, if you remember, we were actually creating a hash to pass for the previous block's hash. And that's incorrect. We probably don't need that. Adding it wouldn't really matter, but just for the integrity of the data, and when you're looking at it, we probably just want a 0 there just to represent, hey, there is no previous block. This is the Genesis block. So I just wanted to make a quick note of that. Back in our main C++ file, we've set up the data for the initial added block, the first added block after the Genesis block. And Joe's going to send Sally 1.5 awesome coins. And then we're setting up some more transaction data where Martha sends Fred 0.2233 awesome coins. And then we add that to the blockchain. And then we're going to use that print chain function that I showed you earlier just to print out what's in the block so we can see what's in there. So let's go ahead and run this. And you'll see the build succeeded and we have 3 blocks in the blockchain. All right, so let's take a look at this first one here. So we've got an index of 0 because this is the Genesis block, and 0 amount. Sender is Genesis, receiver is Genesis, and then we have a timestamp and the hash of this block, and then a previous hash, which is 0, which means, hey, this is the first block. It doesn't have a previous hash. Is this block valid? 1? Yes. So next block, we've got Joe sending Sally 1.5 awesome coins, and we've got a hash, and we have a previous hash. And if you notice here, this previous hash matches up with this hash. And then we've got a third block here where Martha sent Fred 0.2233 awesome coins. And then the previous hash matches up with the previous block's hash again, giving our blockchain integrity. So we see here that this block is valid and the chain is valid. All right, so now I'm going to just show you what would happen if somebody tried to get sneaky. So we are going to uncomment all these lines. And you'll see here that we are getting a pointer to the latest block in the chain. And with that pointer, we're going to access that block's data member and the amount on that data member. And we are going to change it to 10,000 awesome coins, which again, ordinarily you wouldn't be able to do this because we're going to set that member as private. But this demonstrates how if someone were able to get a memory address, they might be able to do a little bit of manipulation there. However, because this is blockchain, that's not going to work. So let's look at this next line here. We're just setting the receiver key to John. Sorry, that was cheesy. And then we're going to print out the chain, and then we are going to run the isChainValid function just to see if that chain's valid. And if everything went well, then it's not going to be valid because we did some manipulation here. So let's run this again. And you'll see here in the first three blocks, this is the first time the print chain function got ran. Everything's good. Everything's as it should be. And the block's valid, this last block, and the chain's still valid. So let's increase the size of this a little bit so you can see it a little better. So in this last block on the chain, you'll notice that the amount is different than it was earlier. And the receiver key is different than it was earlier. However, the hash is still the same. But when the isHashValid function was run on this block, it returned false because that runs a generate hash on the data that's in that block, and it compares it to the hash that's already contained in that block. And if those things don't equal up, then it's false. The block is not valid, and therefore the chain is not valid, and therefore consensus on the network would not agree, and this block would not be actually accepted into the blockchain. And I may do a future video on how that works. All right, that's all I have for you today. I wanted to show you how we could separate the classes and headers out into their own files and make editing and importing easier, and also how each class has its responsibility for one object. I also wanted to reiterate the importance of linking blocks in the chain together cryptographically by using the previous block's hash in the generation of its own hash, and also that if any data within the block is changed, it invalidates the block's hash. So in my next video, I'm going to talk about how different blockchain technology companies are using blockchain to disrupt different industries. Also, if you haven't already done it, please hit the subscribe button and hit the bell icon after you subscribe so you'll be updated with a notification every time we upload a new video. Thanks a lot for watching, and we'll see you in the next video.